Okay, so this is going to be all about linear systems. Everything you need to know about linear systems here. First off, you should have the idea that a linear system is two different lines, and that's why it's linear. That's why the phrase linear. And then systems, that's representing that the fact that we have two lines. It could be two or more actually, but here we have two separate lines, and the solution is where they intersect. Okay, so we're going to go through all that. I'm going to go through everything here, and that all that you need to know about a linear system. All right, so the first thing we need to know is, and the first thing that you see in the chapter is a solution or not. So we know that the solution is where the two lines intersect. Okay, so if you're checking it algebraically or through the equation, you need to plug in the values. So if I plug in 1 and 5 here for the x and the y, I needed to get a truthful statement. So if I plug in 5 for the y, I get 5 equals, and I get 3 times 1 plus 2. Is that a truthful statement? Well, I get 5 equals 3 plus 2, which is true. So that's good. But I have to check it for both of them. Not just the first one, but for both. So if I plug in 1, I'm going to get 2 times 1, 3 times 5. If you do that, you're going to get 2 plus 15, which is 17. That's good. So it's true for both of them, so yes, it is a solution. All right, so that's the first thing you need to know is, all right, can you check your answer just to see if it is a solution or not? Second thing you need to know is solving graphically. If you haven't done this yet, if you know what you're doing, you should probably just check to see if you can do this. So you should pause the video and go ahead and do it. Okay, hopefully you've paused it and tried this, but let's go ahead and graph y equals 2/3 x plus 1. So it's still going to start at 1, and it's going to go up 2 and over 3, 1, 2, 3, and get that second point, and I've got this line here. The other one is going to start at 5, 1, 2, 3, 4, 5. I'm going to change colors here. 5. And the slope is negative 4, so that means it's going to go down 4. 1, 2, 3, 4, and over 1. So with graphing, you're going to get an approximate value, unless you're using a graphing calculator. There's another video on my website to see how you use the graphing calculator to solve it, if you're interested. This looks like an ordered pair of, if you count it out, 1 for the x, so it's 1. And here's 1 for the y, and here's 2 for the y, so it's about halfway between there. So it's 1 comma x for the x, and about 1.5 for the y. And so that would be your solution to this thing graphically. Your answer may be a little different than mine. When you're graphing it, it is going to be an approximation. So understand that it's approximation unless you're using the graphing calculator to get that answer. If you're using graph paper and using a ruler, your approximation is going to be pretty close, so it wouldn't be very far off. But if you're freehanding this, then it goes a little bit more approximate. The next thing is solve by substitution. Now the format that you're going to usually want to solve for substitution is when you have a y equals or x equals. Otherwise, you're probably going to use the elimination method. So I'm going to show you a y equals 1. Okay, so you have a y equals or an x equals. That's the kind that you want to usually solve by substitution. So you're going to go ahead and plug in. It's the idea that, as I given in class, the example of $5 bill, you know, it's equivalent to 5 ones. They have the exact same value, so we can interchange them. If I hand you a $5 bill and you have 5 ones and you give them to me, we're good. We're both equal. So no big deal. The idea here is that y is equal to 2x plus 3. So this is y. So y is 2x plus 3. So if I rewrote that second equation here, second one's here in red, if I rewrote this, I'd have 3x plus 2y. But y is also equal to 2x plus 3. Hence, I'm going to write 2x plus 3 there. And now I'm going to solve this. So to solve this, I want to go ahead and distribute. This is normal equation solving now at this point. So I get 3x plus 4x plus 12 equals 13. And then it's going to give you 7x. And the 12 is going to go across. Okay, I paused it for a second there. I'm like, something's wrong. This is not 12 here. This is actually 6, because 2 times 3 happens to be 6. So anyhow, so I have 7x plus 6 equals 13. So now if the 6 comes across as a negative 6, it's going to give you 7x equals 7. Hence, x equals 1. That's half my solution. So then I go back and I plug in x equals 1. So we're x, and I can choose either one, but this is easier to use here. So if I plug in the 1 now, I'm going to get 2 times 1 plus 3, which is 5. So 1 comma 5 is my solution. That's solved using the substitution method. It's a lot easier, obviously, when it's whole numbers, but it doesn't have to be a whole number. I'm going to give you 2 examples of solving by elimination. The first type is you're going to be adding the 2 lines together. And the one thing I do want you to know is that when you add the 2 lines together, you're either going to get a vertical line or a horizontal line. That's the idea. So if you were to add them together here, we're going to get this 7x, and look at, lo and behold, these y's get canceled out. That's the goal. We want to eliminate one of the variables. And so this is going to be 21. So then x equals 3. So that's half my answer. So then I go back to one of the original. Doesn't matter if it's equation 1 or if it's equation 2. I'm going to plug it back in. So if I plug in 3, I'm going to get 2 times 3 plus y equals 8. So that gives you y equals 2 here, because you're going to take this is 6. It comes across, and so it's going to be y equals 2. So this is a very simple elimination problem because it's already set up for you. You already have opposite coefficients because this was a positive 1y, the other one was a negative 1y. So now we're going to do one that's a little bit more challenging. You're going to have one that is not going to be set up that way. Okay, so this is one that's not set up that way. So you want to eliminate either the x or the y. If I was trying to do this using substitution, this would be a really sort of a difficult problem here. So I need to get, so I have opposite coefficients. I can eliminate either the x or the y. It does not matter. In both of these cases, it's about the same difficulty. So if I multiply, I can multiply these equations by any number as long as I distribute to every single term. So the first, second, and third term, if I multiply that number all the way through, it will stay balanced and stay equal. So the first thing, I'm going to get rid of the x's here. So if I look at the x's here, I have 3x and I have 2x. What 2 numbers does 3 and 2 both go into? Well, 6. So I need to multiply this one by 2 to get to 6, and this one by 3 to get to 6. Now, that makes this one 6x and this one 6x. Well, if I add 6x and 6x together, that's 12x. That's not going to do us any good. Instead, I need one of them to be negative. So I'm going to make one of them negative. I'm going to make this a negative 3 here. And I'll distribute that. So now I'm going to distribute each of these values. So I'm going to distribute and get a new set of new looking equation, even though it's the same one. I get 6x plus 4y equals 32. There's a 32. And then the bottom one, I'm going to get negative 6x, because it's going to the first one. Negative 3 times 5y is negative 15y. And negative 3 times 18 is going to be negative 54. Okay, so once I've done that, now I can go ahead and add the 2 equations. I can do that because 6x and negative 6x will cancel each other out, which is good. So 4y and negative 15y makes negative 11y. And 32 minus 54 is negative 22. Now I need to solve that. So I need to go ahead and divide by negative 11, so y equals 2. That's half my answer. Go back and plug it back in. So it doesn't matter which one you choose. It really doesn't. So let's use the bottom one this time. So I'm going to plug it into the bottom one here. I got 2x plus 5 times 2 now, because that's what y is. And you get 2x plus 10 equals 18. So that, if I solve that, you're going to get x equals 4. So 4 comma 2 is my solution. Alright, next one. Okay, story problems. You need to look at the fact that, right now we're doing linear systems, so you know that it's going to be a linear system. That means you can have 2 forms, either y equals a plus bx, okay, or ax plus by equals c. So you're going to have one of these 2 types. We know it's, we're doing a linear system here, but what about in the when you go into the future and take your final exam? You've got all sorts of different questions. You might be just writing a linear function, not a linear system. And so you need to figure out, okay, am I dealing with a linear system, or am I dealing with just a linear function? Well, the fact that this problem here, it says Pablo is trying to get a new cell phone. Company A charges $100 for the phone, but only $40 per month. company B charges $50 for the phone, but $60 per month. Okay, and so you have two companies, so you have two situations, hence you have a system. That's why it's linear systems. And these are both linear problems because you're adding $40 per month. The other one is adding $60 per month, so they're adding a constant amount in terms of what you've paid for the phones. So we're going to go ahead and write a system. The fact that you have an initial amount and you have a constant addition or of a value, that tells you that it is the first kind right here, that it is y equals a plus bx. So company A it's going to charge you $100 initially. That's a startup. That's what A represents. And then it's going to be adding $40 per month. And so that's company A. Company B, however, only charges you $50 for that phone. But it's going to charge you $20 more. Oops, I shouldn't have done that. It should be $60, which is $20 more than $40. And now the question is, when are they equal? When's company A better than company B and vice versa? So, and it really is, because one company is going to be better than the other one. If you're a person that loses your phone right away, then you're probably a person that's going to choose option B. If you're a person that keeps your cell phone well and doesn't drop it in the water or anything like that, then you're going to want to go with company A. So one's going to be here, it's going to start at 100 and going to go up by 40, and the other one's going to start down here at 50, and it's eventually going to catch and it's going to intersect here. So if you do substitution at this point, set them equal to each other, you get 100 plus 40x equals 50 plus 60x. I'm not even going to go through the whole process of solving this. You'll find out that it's just 20x equals 50. So after 2.5 months, if you do this after 2.5 months, the option A is actually better. But that initial 2.5 months, because x represents months here, a lot of people choose company B just because they have that initial cost. They don't have $100 on it, but they have 50. Like, ooh, all right, sounds good. Yet it ends up costing them a lot more money in the long run because they don't think about it. Assuming these phones are equal, then they definitely should choose company A, because they will pay less over the long haul. Most people keep their phones for 18 months. That's how long they're designed to last, that long. And so how much would you actually have saved if it's going to last you 18 months? And the one is going to be 100 plus 40 times 18 for the 18 months. And the other one's going to be 50 plus 60 times 18. Okay, and so the difference here is, so company A is going to end up charging you $820 over the long haul. Company B is going to charge you $1,130 over the long haul, and for 18 months. And if you keep your phone longer than that, it's going to even be a greater difference. But on average, people then would be saving $310 if they chose the better company. There's other things that go into it, of course, in terms of cell phone coverage and all that kind of stuff. But this is a pretty good idea just in terms of the money sense, which one would be the better choice. Second type of story problem is one that's going to look like ax plus by plus or equals c. This one usually has a hidden total equation, so hidden total, okay, and it'll say something about like there's so many candles or vases sold and that kind of stuff, and it's a total equation. You're going to see an x plus y equals whatever that total number is. That's the hidden one that's usually that people don't recognize. Okay, a story problem example. Timmy is selling bikes. Used bikes cost $100 and new bikes cost $400. He sells a total of 10 bikes. 10 new bikes. He sells a total of 10 bikes, not 10 new bikes. 10 bikes, and receives $1,200. Okay, so this is a situation where we have bikes, which we call X. Used bikes, which are X. New bikes, which we'll call Y, because we don't know how many of each. You can actually guess and check this really quick. You know the answers. If you're good at guessing and checking, you know right away that the answer is, I think, well, there's no rewind button, so I had to pause and I just real quick did this. The answer is supposed to be $1,600, not $1,200. So anyhow, so much for proofreading. So the answer is going to end up being 8 and 2. Now we can guess and check that and probably get that, and it works out fine because we have whole numbers, that kind of thing. But let's go ahead and humor me and go through the problem here. there's a total here, a total of 10 new bikes, or 10 bikes, excuse me. So x plus y, used plus new, is 10. And then he's going to get $100 for every used one, and $400 for every new one. He's going to get $1,600. If you solve this equation, you'll end up getting 8 and 2. So that means he's going to sell 8 used bikes and 2 new bikes, and he's going to get a revenue of $1,600. So you're looking at this and you go, oh, okay, that's something I could probably guess and check at, but we think linear, so that's why it's easier for us to do. But again, the fact that we have a known total, that gives us a total equation, and then we also have two different variables here, used bikes and new bikes, where if you go back to the other problem, go back here, you have month is one variable and the other one has per month, so they have the same variable, which would be x. Here we have used bikes, which is x, and new bikes, which is y. And the next thing that you need to be able to do is special solutions with linear systems. So normally our graphs will be something where they intersect. It's like one graph, second graph, they intersect at that point right there. Boom, you have your special solution, not here. I mean, this is a unique solution, I should say. So there's two types of special solutions. There's infinite solutions, and there is no solutions. Okay, so what do they look like? What happens if you look at a graph? What do they look like? Because in a regular solution, you see them intersect at a singular point. Infinite solutions, it'd be if you graphed one line. Okay, here's your line, like the sound effects. Okay, and then you graph the second line, and lo and behold, it ends up being the same line. And that's a case of infinite solutions. So if this is a college class, you wouldn't just write infinite solutions. Say this is an example of y equals 2x minus 1. And the other one was some variation of that, but it still was the exact same line when you graphed it. So they're the exact same line. In college class, you would actually write for all x, that fancy looking x, all right, such that the order pair xy is on, let's see, for all x, whoops, I guess I should have done that a little bit differently. Here we go. Okay, here we go now. For all x comma y, such that, that's what that vertical line means, such that y equals 2x minus 1. So that means there's an infinite number of solutions here. So all the order pairs, so that's what this means, all of the order pairs, all of them, that's what this upside down A looks like, such that y is equal to 2x minus 1. So an example of this would be if I plugged in 2, 3, 2, 3 is a solution here. There's a ton of them. But if I plug in 2 into this, I get 3 equals 2 times 2 minus 1, which is true. That's one of the solutions. So 2, 3, which falls in this line right there, that's one of the solutions. Well, guess what? So 0, negative 1. So as many other ones. And that's what infinite solutions. In high school, you do not need to write this way, but in college you would. All right, so infinite solutions continued. If you're not solving it graphically, you might not, you won't see that they're this same line. So what happens when you're doing it using an equation method? So like if I use the substitution method here, I have y equals 2x minus 1, so I plug that in, what will happen? Well, at the end, you end up getting a truth. You get a truth, something that's always true. So like you might get a number that says like 5 equals 5, or 2 equals 2, or 0 equals 0. It's like one of those things where you're going and doing the problem, you're like, hold on, this isn't right. And that's what happens with a special case. So I'm going to get negative 6x. If I plug in this, I'm going to get 3. And I plugged in 2x minus 1. Okay, and that's equal to negative 3. If I distribute this, you're going to get negative 6x plus 6x minus 3 equals negative 3. And these cancel out. I get negative 3 equals negative 3, and you're like, what's the answer? Well, that's a truth. Everything canceled out. That means we have a truth. Hence, my solution is infinite solutions. It's not all solutions, it's just infinite. And finally, let's go on to the other one. No solution would be when you graph it and they graph and they are parallel. So that's the key thing, is that they're parallel. Alright, so parallel is no solution. So we need to go ahead and solve one, look at it, see what happens when you're dealing with an equation here and see what it looks like. Y equals 2x minus 3 and y equals 2x plus 5. They're parallel lines. They have the same slope. They have different y-intercepts. So if you were to graph them, you looked at and you would see going through -3 and the other one's going through 5. And they have the exact same line. So now if I solve this using substitution method, I'm going to plug it in. And I get everything to cancel out, but this time I'm going to get a lie. This time there's a lie that's going to occur. Therefore, no solution. Alright, so no solution would be my answer. You can also write the empty set. That means no solution. So it gives me 2x minus 3 equals 2x plus 5. And if I solve this, subtract the 2x's across, well, what do you know? They cancel out. So that gives me -3 equals 5. Well, that's not true. Therefore, I get no solution. And you can make that empty set, which is called the null set, that also works. Hopefully this has been very helpful to you, and hopefully a good review for everything that's going on with linear systems.